Hello everyone, we're Group 5 and we're going to introducing the Carpool system. And now let me introduce my group members, Feng, Wang, Yameng, and myself, Wang. The topics we're going to present are background introduction and the solutions we will provide to solve the problems, and the analysis tools we used in this project, which are context diagram, use case diagram, sequence diagram, class diagram, database design, and finally we will come to the conclusion. The background introductions. We're facing the traffic problems every day because when we're driving to work or school, because of the rise usage of vehicles. For the same reason, air pollution is also a problem we're dealing with. In the meantime, some drivers just want to share their empty seats with someone else and make some money while driving to their destination. For example, if I want to go to Houston, it's like 4 hours driving. I can find someone else to go there with me. It will make my travel more interesting and will also share my gas money. The issues I mentioned before can be somehow fixed by our system. The system will analyze the request from drivers and passengers, such as where they want to go, when, and the number of people in their group. Then the system will provide a list of the options for our customer. They can pick one in the list or just simply make a new request. And our system has a new feature, which is the event promotion. The system explores the nearby events and provides the information to our users. Then, if they are interested, they can simply find a group of people to go there together. These pictures are from our design of the user interface. It's just a simple app that you can download to your cell phone. And we have 10 more pictures in our final case report.
Next, we'll talk about context diagram. From this diagram, we can know that this system mainly interacts with three entities: the passengers, drivers, and bank. The passengers first have to register and log into the system and then set up their account. Then they can use the system to find their drivers for both real-time and future carpool. We have a request list recording all the drivers' available time and driving routes. Passengers can first search and then find one driver, then send requests to him or her. When driver confirms the request, and then they make a reservation. After the carpool, the passengers will be charged with a specific amount of money, and it's from his credit card, and driver will receive the same amount in his or her bank account. And for drivers, systems work similarly. They also need to register, log in, and set up account with more required information. The difference is that system searches in the passenger's request list and to make a match, and the driver only receives money. And for the bank will receive payment requirement, do the transaction, and send back the confirmation. Then we will see our use case diagram. On the first level, we have 6 use cases: log in, register, review, make a payment. The most important one, make a reservation, and our new feature, carpool for events use case. Because make a reservation is complicated, so we developed the second level use case to better describe it. In this level, we have 4 use cases: search and match, search by event, post a new request, and price estimation. Login, review, and make a payment work like other systems. Register. We can register as passenger or driver. The required information is different. Passenger need to provide credit card information, and drivers need to provide vehicle information, driver license information, and bank account. Make a reservation is the most important use case. It starts with search and match. To search for a driver or passenger, we can choose to search by criteria or search by event. If passengers choose to search by criteria, they need to input information like pickup date, pickup place, and destination. Then system run price estimate use case to provide a list of available drivers and estimate prices. Then they send a request and confirm the request, and finally make reservation. If no available driver is found, user can choose to use post a new request use case to post his or her desired time and route in passengers list so that some drivers may read and send a request back. And the driver's request will be updated in the driver's request list. If we choose to search by event and search by event use case starts, we need to enter event type like sports game or music concert and time. A system will search through the event list and display result including registered passengers or drivers for that event. So they can send requests to each other and confirm request and finally go to the event together with a lower cost. They can even make friends because they share the same hobby. Carpool for event use case is designed for people who want to find carpool for an event easily. All events will be listed by category. You can see any category according to your hobby. You can also search by time and category. If you do not find one that interests you, you can post the event yourself and wait for others to join you. Price estimate use case will estimate cost according to driver's vehicle information like miles per gallon, pickup location, destination. Final value will be displayed with driver's list.
After use case diagram, we will introduce major sequence diagrams, which are make new reservation, post new request, make payment, and write review. For make new reservation, passenger or driver could choose to search by criteria or search by event. If user chose to search by criteria, system will require user to input travel information such as starting location, destination, and travel date. If user chooses to search by event, system will ask the event database to search all the events that are near the user's current location, and the database will return an event list and show the list to the user. After user input all the required travel information or choose an interested event, system will then search for the matching request in the request database. Also, system will require the price estimate after finding the matching request. The requests database will require gas price and calculate the estimate price and then show with all the request list to the user. After user select an interested request, the system will send invitation to the other user who has posted the request. And if the other user accepts the invitation, system will sign an agreement and inform both parties. If user could not find a proper request to make new reservation, he or she can also choose to post his new request and waiting for others to search him. System will create requests in the database according to the user type. If user is a driver, system will create new driver request. And if the user is a passenger, system will accordingly create a new passenger request. And then system will inform the user that a new request has been created and saved. When passenger arrives at his destination, he can click Finish Trip to make payment. System will require the user to confirm the payment. And the user can also choose to add tips. Then system will inform driver about the payment. Also, system will send payment request to the bank. If all the payment information is right, bank will approve payment request and transfer money from passenger's credit card account to the driver's bank account, and also inform both parties about the transfer. After the trip, both passenger and driver could choose to write a review for the other party. They can start a new review by click the Provide Review button, and the system will require the user to input rating for the trip and a comment for the trip. After user has provided rating and comment, system will instantiate a new review in the database and inform the party who has read the review. Also, the database will update the rating of the person who is reviewed in the driver or passenger database, and the driver or passenger database will then recalculate the overall rating of the person.
Here is our class diagram for our project, and which shows the main building block of object-oriented modeling. And the majority class for our system is the user, which contains the first name, last name, email, and so on, this kind of attribute. It also contains the select request, send invitation, accept invitation, sign agreement, provide rating, and provide comments. And this parent class also contains two child class, which called the my passenger info and my driver info. They inherited the method and attribute from the user class, and also contains some unique methods themselves. And also there are three classes called the travel history, new request, and review class associated with the user class. We also have the register and login class to control the access to our system. So here is the domain of our ER diagram for our database design, and we use the primary key integrity constraint, referential integrity constraint, and the uniqueness constraint to control our database design. And for the user table, we use the user ID as a primary key. And it also contains two child classes associated with it, which are the passenger and the driver table. They both contain the user ID as their primary key and foreign key. And for the driver table, it also associated with the vehicle table. The vehicle table will contain the vehicle ID as a primary key and the user ID as a foreign key. For each of the passenger and driver, they will have a request associated with them, and the request will have their unique primary key, and also take the user ID as a foreign key. And for each request, they may associate with the special event, so we also take the event ID as a foreign key in the request table. One event may associate with the 0 or many requests, and one request may relate it to 0 to 1 event. And for each request match with each other, we will have a reservation table for them. The reservation table will contain the reservation ID as a primary key, and also the unique primary key from the request table as a foreign key in the reservation table. Now let's go to our final part, the conclusion. We provide easy and friendly interface associated with an affordable and safe system. The use of mobile phones makes our system easy to use everywhere and every time. Specifically, my event function provides our users more possibilities of finding a driver or passenger who has the same destination or even the same interest. This is more like a hobby group rather than a one-time driver-passenger relationship, which will satisfy their social requirements at the same time. So as we said before, there are always countless of problems we are facing, the pollution, greenhouse gases, meeting new peoples, and so on. No single system will be a silver bullet to address all these problems. However, we hope that our carpool system could provide a positive impact on our daily life and our planet. That's all for today. Thank you.